Hello guys, my presentation is going to be based on biofuel from waste. We're going to talk about what biodiesel is and how we produce it, and we're going to talk about how we can get it from textile wastewaters. And as we all know, when biodiesel is produced, it also produces crude glycerol, and we're also going to talk about what we can do with that. So we all know the biodiesel is biodegradable and it's not toxic and it's free from sulfur and it's not carcinogenic to us. So that is good. But biodiesel is generally more expensive to produce than diesel, but I have had different sources stating different things, so I am not completely certain on those two. So as we know, there are multiple ways of producing biodiesel. We did it in semester 1 with waste cooking oil, but we're going to talk about microalgae and algae. Microalgae are unicellular species which can be found in freshwater and marine systems, and they're quite good for cleaning industrial wastewaters, as it's free of we can use it freely, and we don't have to worry about expensive chemicals and things like that. And this is also a good weapon against climate change, as they take away carbon dioxide from the atmosphere. So the microalgae can use atmospheric carbon dioxide as a carbon source along with organic dyes, and through photosynthesis they can produce sugars or carbohydrates. From carbohydrates we can convert these into lipids, and chemically or biochemically, and these lipids can produce biodiesel for us. Microalgae also use less water and then fuel crops, and they also use less land, take up less space as well, and can remove toxic metals from the wastewaters. I've highlighted 3 species as can be seen. Each of the species has a different way of obtaining the nutrients. For example, the heterotrophics can obtain glucose into convert glucose into lipids by the absence of light, whereas the autotrophs they need some form of light. Algae can be cultivated using raceway ponds, which are these here, and or circular ponds. There are other ways of using them, but these are like the most common ways which I could find. They need nitrogen, carbon, and phosphorus, which are essential for their growth, and they can take 1.83 tons of carbon dioxide out of the atmosphere. This is a lot more than traditional fuel crops. We can see by these equations that are here, the carbon dioxide can change the pH of the water. Microalgae use the bicarbonate ions for the lipid growth and lipid production, and so forth. Microalgae is difficult to harvest as they are water-based, and they are generally harvested using chemical, biological, or mechanical, electrical methods, as can be read of here. Filtration does tend to be used, but it's quite difficult to do because each cell will have different size, and you need a different filtration system for it. You can read about centrifuging, and enzymes are used as well. Enzymes generally tend to be better. They're expensive as well. As you can see, biodiesel or microalgae, we can produce this much amount of it, which is a lot more than when it's wet, or like from any of these other crops. And we can do this by reacting triglycerides with using an acid-base kind of catalyst, which will produce glycerol and biodiesel. And from microalgae we can produce any of the following things, you name it. The crude product which is produced with biodiesel is often thrown away, and this will over-accumulate because there's lots of industries which produce glycerol, and so we can get rid of this and get biodiesel again. But you have to first we have to get rid of these things called soaps, which are soluble salts in the crude glycerol, and from this we can get free fatty acids, and we can form biodiesel through this process, esterification, and also we can get the purified glycerol and use that from using microalgae and things like that to form lipids, which can also make biodiesel. And so pure glycerol is obviously going to be better than purified glycerol in the production of biomass and growth rate, because the purified glycerol may still contain impurities which will cause the microalgae not to grow properly. As can be seen from the image, the figure, I should say, we can produce a lot of biomass, and as a result, we can produce a lot of biodiesel. And crude glycerol can also be used to generate hydrogen gas, and this is done through a lot of biochemical reactions and the use of enzymes. As can be seen here, this is the different way of doing it, and this is the chemical reaction at the bottom here, and this is how it look like at the top. We just need to remember this equation as a chemist, and that's about it for us. It will look like this, and there will be impurities. If there are impurities present, it will reduce the amount of things fermented. Carbon dioxide will produce as a result of this as well, but it can be taken up by the microalgae or the bacteria, which